Okay, distance between two parallel planes. So I've already given it away, but we have our two planes here. And let's say they just asked us to find the distance between these two planes. First of all, what we need to do is figure out if these planes are parallel. If they're parallel to each other, we're going to be able to find the distance. Otherwise, if they're not parallel, we're going to have intersecting planes, right? And then there really is no reason to find the distance between the two of them. So let's double check. We'll quickly look at the normals to both planes. The normal to the first one is 2, -1, and 2. And the normal to the second one, 2, -1, and 2. Perfect. So both of our planes are parallel. Just like before in 9.5, we need to find a point on the plane because our equation solves for a point to a plane. So what we're going to do is we'll take, for instance, the very first equation, or the first plane, and let's find the point where it intersects one of the axes. It's easiest to do that because we're going to know two of the coordinates already when we go through an axis. For instance, if we're solving for when it intersects the z-axis, that means we're at x when x is equal to 0 and when y is equal to 0. So our coordinate is 0, 0, 1, which is great because we can plug it right into our Cartesian form of the plane. So when we do that, we're going to take plane 1 and we're going to find a point along it. So our x value is 0, our y value is 0, our z value is 1. Sorry, no, our z value is what we're looking for. Should have said 1 there. Technically is what it is. We're looking for our z value. So 2z plus 4 equals 0. Those cancel out. We're with 2z is equal to -4. Z is equal to -2. So our point is at 0, 0, -2. So that is going to be the point for our equation. Okay? That will be our x naught, y naught, and z naught. Now that we have that, we're just plugging into the formula we had before, but we're using the other plane. We're not using the same plane, otherwise there's not going to be any distance between the two numbers. So our formula again, I'm just going to go directly into it this time. A naught is 2. So 2 and x naught is 0. Minus y is just 1. And our x or y naught value is 0. Plus 2, our z value is -2. But our d is 16 in this question. So that's the absolute value of that. And then it's all going to be above the root of a squared, b squared, c squared. And we know our a, b, c from just looking up above and from kindergarten. So 2 squared plus 1 squared, or -1 squared, plus, again, 2 squared. That's exactly what these terms were here. From there, we're going to get 0. Subtract 0. -4 plus 16 is going to give us the absolute value of 12. Over 4 plus 1 plus 4 is root 9. We're then left with 12 over 3, which is 4. So the distance between these two planes is a multiple of 4, or a number of 4. Okay. Now, there is a part B to this, and it asks us to find the equation of a plane that is equidistant from the first plane to the second plane. Okay. Well, the good part about this is we know they're parallel planes, and we did solve for one of the points. We solved for when the first plane crossed the z-axis. We can do the same for the other plane since they're parallel. Okay, so we'll zoom back in again. So stay with me on this concept. Think of it like this, part B. One of the planes crossed here at, oh, that doesn't make sense, not at -2. -2. So one of the planes crossed here at -2. The coordinate 0, 0, -2. The other equation, we're going to find the exact same thing when it crosses the z-axis. Okay, because they're parallel planes, they're going to be equidistant when they cross the z-axis together. So our other formula, so plane 2, we're going to find the exact same thing. We're going to plug in 0, 0, and solve for when it crosses the z-axis, which is then going to give us 2 times 0 minus 0 plus 2z plus 16 equals 0. That becomes 2z equals -16. Z is negative 8. So it's even below. It crosses at negative 8. 0, 0, negative 8. In order to find out what would be halfway between, we're going to add these two numbers and divide by 2. If you guys remember your trig functions, this is like finding the equation of the axis. So we take negative 8 plus negative 2, and we're going to divide it by 2. That gives us negative 10 divided by 2, negative 5. So a plane that would be equidistant from them is going to fall in between the two of them, right in the middle, and it's going to cross the z-axis at 0, 0, negative 5. But they want the formula for this plane. Well, we know it will be parallel, so we know that our third plane, we're going to call it plane number 3, the normal will be the same, so we're still going to have 2x minus y plus 2z. The only thing is we don't know the d value. It'll be equal to 0. We're going to plug in our points at 0, 0, negative 5. So 2 times 0 minus 0 plus 2 times negative 5 plus d equals 0. Well, we're going to get negative 10. D is equal to the value of 10. So their equation is 2x minus y plus 2z plus 10 equals 0. That would be the equation of the third plane in this question.